Hello my dears, today we will be talking about how to read a heating curve, and that is this diagram that you see here. On our y-axis we have temperature change, and on our x-axis we have the change in thermal energy or heat. You're also going to see a constant slope, so basically this flat line here for going from A to C, and then over here going from C to E. So wherever you see a flat line, that's going to indicate that a phase change is happening here. Now, in a phase change, we are adding energy, but the energy is being used to separate molecules. So this is why our temperature doesn't change. During a single phase change, the energy makes the molecules move faster. So that's why the temperature changes. So basically, we're going to see a temperature change when you're going on these diagonal slopes here. Okay, so anytime you see a diagonal slope, that means that you are undergoing a temperature change. Okay, and anytime you see this constant slope that's indicated in the yellow here, that's going to be a change in phase, which will change the potential energy. So what we are observing here is, I want you to imagine water. Okay, when you have a solid water, that is ice. Liquid water is just a cup of water. And gas is going to be our steam. Okay, so our phase changes are here. If I am adding heat, so heat, remember, heat is being added or heat is being removed. Okay, so if I'm going to the left, I am removing heat. Remember, if you are removing heat, that's exothermic. So going from a solid to liquid, I'm adding heat, so that is melting. If I'm going from a liquid to a solid, I am removing heat, so that is freezing. Similarly, in our liquid to gas, okay, if I am going from a liquid to a gas, that's vaporization, also known as boiling, so that's how we get our steam. And if I'm removing heat, I'm going from a gas to a liquid, and that is condensation. Okay, so again, these lines are flat here because we are showing that the energy is being used to separate the molecules. And because it's being used to separate the molecules, the temperature is not going to change. Okay, but the temperature does change when we are changing kinetic energy. Remember, kinetic energy is the energy of movement, and we cannot have an increase in kinetic energy without increasing the heat, okay? Because the more heat we have, the more the molecules are moving faster. Therefore, faster movement means more kinetic energy. So this is how you would read a heating curve. Normally it's done for water. It can be done for other substances. But the important thing to understand is what's happening during a temperature change, which is the slanted lines, and what's happening during a phase change, which is just the flat line. Again, with a phase change, energy is being used to separate molecules from each other, not to break the bonds, okay? Because remember, if you break a chemical bond, that's actually a chemical change, okay? What we're doing right now is physical changes only. With a physical change, we are not altering the chemical makeup of that substance, okay? Because if you break a bond, you're actually causing a chemical change. You are altering that substance. Everything we're talking about here, these are phase changes, so that's physical, okay? So when I am separating these molecules, that is a change in potential energy, okay? But when I'm actually adding heat and, I'm actually in a new phase, that is a change in kinetic energy. Okay, I will see you guys the next time.